Hi! On previous video I've shown you how to apply simple automation to the system using data pipes. Now it's time for some more complex concept. Let's explore the controller library. In this video I'll just briefly describe the idea and show you some basic example of controller usage. Next time I will present something closer to real life scenario. We will add central heating system to our smart home. So first things first, let's start from some theory. Controller is a Node.js library which works both in Node.js environment and web browser. Main difference between these environments is that discovery service that is able to automatically find local server is not available in browser, so in such case you need to provide server URL yourself. If controller is used as Node.js process, discovery happens automatically, same as with device library. In opposition to device library, you can start any number of controllers within single process and each controller can be connected to different server. That is because controller is not declaring any values itself, it's just accessing existing values declared by existing devices, so there is no need to uniquely identify each controller instance. Controller uses system model to interact with all components existing within system image. Exact structure of system model is posted on controller reference page. What's most important here is model map and model value concepts. Both classes encapsulates read-only content and contains subscribe method which allows you to register a callback that will be invoked if their content would change. Controller takes care of updating model maps and model values whenever such need arises. There are two things you need to be aware when using system model. First one is related with GateValueModel class. As you can see on the diagram, it contains GateValue and model value fields. As already mentioned, model value is meant to be read-only, so if you want to change the value of an input, you need to call GateValue.setValue method. Additionally, Stargate tries to save bandwidth, so model value of GateValueModel will not receive any updates from server until you explicitly subscribe some callback to it. The second matter worth pointing out is how system model manages devices model map. Whenever a device is joining local server, it sends its manifest during handshake. It can happen that current device manifest is completely different from the one previously stored within system image. There is always a chance that you refactored its code in the meantime. That's why device model of joining device is not getting updated, it's replaced with a new one. It might be a bit problematic if your code is meant to interact with specific gate value, as you not only need to find it within system model, but also repeat this operation every time device model is replaced. To simplify that, device subscription class have been introduced. All that may sound a bit complicated, so let's see some example implementation. Here is a link to simple controller example. Let's download it and see how it works. As you can see, first we defined a device. You don't need to use device along with controller. Libraries are totally independent, but in this case it's simply convenient to move the output to user interface instead of playing with console or something similar. By looking on device code you can figure out what the controller will do. It will simply track the state of some specific device in the system and show if it's online or offline. Obviously it's not a especially useful functionality, user interface already does that, but it's purely to demonstrate the basics of controller library. We will do something more fancy in next video. So first we need to get our system model. That's actually pretty simple, you just need to call getSystemModel method and all the magic happens automatically. Optionally you can pass config object to the method if some default settings requires adjustments. Next we define a function that will be called by device subscription every time the model of observed device would change. It checks if received model is defined. If not, it sets observed device state to false, which corresponds to offline state. Otherwise it sets the state according to current device state and subscribes state model value to update observed device state when necessary. Now we can create device subscription. We give it system model on which it is supposed to operate. Next we give it a matcher function that defines which device to pick. This time we are looking for device marked with specific string on its info field. Finally we give it initializer function that will be invoked whenever device model would be replaced. And we could actually stop here. Our controller is ready to perform its function, but we can do one small optimization. We don't need our controller to track changes in system model all the time. It's necessary only when somebody is watching observed device state. So as last step, we close device subscription if nobody is subscribing observed device state at the moment, and add onSubscriptionChange callback to it to open and close device subscription as needed. That would be it regarding code. Let's start our controller. Okay, we don't yet have our observed device available in system, so its status is offline. I will start dummy switch from video about Node.js device. I just need to set its info field to what our controller is looking for. And observed device state changed to online. Fine, now device started from our controller is aware of state of another device within the system. I guess that's enough regarding introduction. Now it's time to play with something more complex, but that's subject for next video. If you find this content useful, don't forget to give thumb up or leave a comment. Thanks for watching and see you on other videos.